So once again, afternoon, and welcome to System Software and the module essentially covers computer technology in a very general sense. So we want to begin with a proper definition. You need to understand a few things before we start embarking on this particular subject. The most important thing with relation to education is you need to understand that you're basically learning new words. So just like you learned the English language and several other languages that you may be able to speak, every module that you're going to be covering is basically an exercise in learning language. So there will be words, and your job is to understand the meaning of those words. So with regards to system software and computing concepts, you're talking about a subject that is pertaining to two aspects: system software and computing concepts. So these two terms essentially are founded in the realm of information technology. So what exactly will we be studying in the module? Well, we will be studying some aspect of information technology. In order to properly highlight that, I'm going to scroll away from the actual slides and I'm going to open up my whiteboard. And from my whiteboard, we are going to attempt to kind of put ourselves in place. So I'm just going to quickly switch my screen here. All right. So hopefully everybody can see my screen. It may take a minute to just load up. There we go. Okay. So the idea that we're beginning with is that we are going to be discussing information technology. All our discussions are going to be founded on this concept of information technology. So what is information technology? The term information means that which informs. Information is made up of pieces of data. So for example, what is data? Textbooks will tell us that data is any raw fact. So for example, if I have the term 35, 35 by itself represents a value, but it doesn't particularly have any meaning. It's just a value. What does it mean? If we add another piece of data, let's say, for example, we say 35 and we add the term years, then these two pieces of data, 35 years, begin to inhabit some sort of meaning. It means to say that we have some sort of object that has been around for 35 years. So if I say Mark, for example, this is the name of a gentleman. So Mark, 35 years. It's now giving me some information relating to this object called Mark, and that this Mark is 35 years old. So pieces of data organized in a particular way form what we call information. And information is simply defined as anything that informs. When we talk about the other term, technology, on the other hand, what is technology? Technology refers to two things. It refers to tools and knowledge. So the term information technology, technology particularly, we can use it to describe two things: tools, things that we make, and knowledge, things that we know. So what do we mean by tools? Tools are any physical objects that we make. So generally speaking, technology is anything that human beings make. It can involve physical things or it can involve knowledge. So if I, let's say, went into the bush, cut down a couple of trees, took the wood and built a table, well, the table that I've built is now a piece of technology. It is something that I've taken from the natural environment and I have converted it into a new form that I am now utilizing. So anything a human being builds is called a tool. Knowledge is the how-to, basically the know-how. So if you look at knowledge, on the other hand, knowledge refers to the how-to. So even developing a method of how to do something is considered technology. What do we mean? Let's say, for example, I invent a new cooking recipe for a cake. So the steps that I take to actually bake that new type of cake can be listed out in a document, and that knowledge, that know-how becomes technology because it's something that I've now created. So technology can be something that is tangible, and it can be something that is intangible. So in the case of where it is something tangible, it's called a tool. It's something that I've built. Where it is intangible, where it's information or technical specifications of how to do something that I've developed, then it becomes knowledge. So it refers to the how to. So what is technology? Anything man adds to nature. And it can fall under two categories. It can be a tool, which is something physical, or it can be knowledge, which is something non-physical. Can I get a quick thumbs up? Is this concept clear? We understand what information is and we understand what technology is. All right. So now, when we use the term information technology, what are we actually doing? We are now classifying or subdividing all of the technologies that exist in the world. And we are saying we want to tackle the subset of technologies that have to do with information. So when we say information technology, we mean all the knowledge and all the tools that have to do with information. So the knowledge and tools that have to do with information have to do essentially with three things: input, process, output. So we are dealing with, when we talk of information technology, all the knowledge and tools that have to do with collecting data, all the knowledge and tools that have to do with processing data, and all the knowledge and tools that have to do with outputting data or storing data or transmitting data for future use. So collecting, processing, storing, and distribution of information. Anything, any tool or knowledge that pertains to this activity will be considered information technology. The most important tool that is in the arsenal of information technology is, of course, the computer. And this is the focus of our module. So when we say system, software, and computing concepts, we are basically talking about the technologies that is a computer. So let's dive into this a little bit more. We want to again start with a simple definition. What in fact is a computer? If you look up textbooks, it will read, a computer is essentially an electronic device that can accept input, process that input via a set of instructions, and produce some sort of output. Now, that definition at some level sounds very plain and bland, but what is the nitty-gritty detail that it's trying to communicate? So let's go through that definition piece by piece in order to understand how to understand computers. Language is very important. Every word has meaning, and your job is to understand the meaning of these words. So when we begin the definition by saying a computer is an electronic device, what in God's name is an electronic device? It simply means a device that operates on the basis of electricity. So anything that uses electrical power or uses electricity to communicate, we call it an electrical device. So our TV is an electrical device. Your PlayStation is an electrical device. Your Nintendo Switch, your phone, all electrical devices. So we said a computer is an electrical device that can accept input. What is input? Input is any signal fed into a computer. For example, right now I'm talking to you and I'm using sound. In order for you to hear my sound, you need to have ears. So your ear is an input device for sound. Without your ears functioning properly, you will not be able to perceive sound. So a computer's input devices are those hardware components that allow signals to be transmitted into the computer. Then the opposite is the output. Those are devices that are used for this computer to generate a signal to communicate with the outside world. So right now in our communication, I am outputting sound through my mouth, and you are inputting the meaning of the sound through your ears. So first, your ears receive the sounds, then it sends it to your brain, then your brain processes it to transcribe its meaning, and then you understand what it is I'm saying. So an electronic device that accepts input and processes it via a set of instructions. So what does it mean? Processing via a set of instruction simply means this. Anytime you're giving an instruction, you can process that instruction based on a set of rules. So for example, right now I'm speaking English, And because you understand the English language, it means inside your head, in your brain, you have the English decoding software. That is why when I speak English and you hear me speak English, you can understand what I mean, because your brain is using the rules and regulations of English to decode what I'm saying. So if a computer is to understand or to process any sort of information, there has to be some sort of instruction that tells it how to do so. For our human communication, English language is the instruction by which we encode and decode. So for a computer, whatever you're feeding it in, if you want it to process, you have to give it a set of rules and regulations. So that set of rules and regulations is what we term software. So software is a set of instructions that tells a computer what to do and how to do it. So a computer is an electronic device that accepts input and processes that input via a set of instructions. And then the last part, it generates some sort of output. So feedback. Now, the idea of the computer is it's a tool. Anytime I want something done, I can ask this tool to perform that action for me. When I ask the tool to perform the action for me, it performs it, and I will probably need some sort of result. So the results are what will be posted out as output. Very simple. So electronic device accepts input, processes it via a set of instructions, and generates some type output. Is this clear to everybody? Can I get a quick thumbs up? All right. So we move on to the next bit. So the title of our module, System, Software, and Computing Concepts, comes down here. On the computer, there are two primary components. The two primary components are, of course, hardware and software. So hardware refers to the physical components of the computer, whereas software refers to the information or sequence of information that the computer obeys. So let's do it this way. You can imagine the software as simply a file that contains a bunch of zeros and ones that are instructions. So the file contains instructions. Instructions to tell the computer how to perform an action. So you can think of it this way. If I went into my kitchen and I wanted to make tea, I would make tea by following a set of instructions depending on what type of tea I want to make. If I want to bake a cake, I will download maybe a cooking recipe. So that cooking recipe is a set of instructions that tells me what to do and how to do it as a human being. But it is exactly the same thing with computer software. So a piece of software like Microsoft Word, PowerPoint, Microsoft Teams, your web browser, are just files that contains instructions that tells the computer's hardware how to operate to perform an action. So for example, if I was browsing the web, I would open up a web browser, type in a URL. When I type in the URL, hit enter. The web browser needs to have instructions that tells the computer what to do with that URL. That is, package this URL, put it through my network interface card, transmit it via my Wi-Fi or via my wired connection to my router. Then my router has to post it to some domain name server to resolve the name, get the IP address of the server I want to connect to, and so on and so forth. So that entire ritual, the steps, the sequence of events that occurs will be programmed by a programmer, a software engineer, who built the web browser software and told it exactly the steps to take on what to do, how to do it, and so on. So this is what software is. Software is a set of instructions that tells a computer how to perform a specific set of tasks. So I can have different softwares for different tasks. So in my computer, I can have many installed programs, and these installed programs will all have different functionalities and capabilities. Right. So moving along, with regards to hardware, on the other hand, the hardware refers to the physical components of the computer. So the physical components of the computer. So these physical components also have been classified into groups. One group is the input devices. The second is the processing devices. The third is the output devices. And then you have the storage devices. And of course, you have the communication devices. Under the communication, we have two subcategories. We have the hardware for communication, and we have the software for communication. So importantly, anything that has to do with communication falls under the realm of networking. So in this module, we will be touching a little bit on networking, but not in depth, because you have another module specifically for networking. Meanwhile, on the other hand, for software, there are two subcategories. We have the important system software, which is part of the title of this module, and we have application software. So we're going to spend some time here to fully flush out the meaning of this. We've said a software is just a file that contains instructions that tells a computer what to do and how to do it, and that there are two types of software. You have system software and application software. What is system software? System software is the main software that controls and coordinates all the activities of a set of hardware. So this is how you want to imagine it. This system software controls and coordinates all of a computer's hardware. So it controls and coordinates all computer hardware. It's your operating system. So system software is another way of saying operating system. So what exactly is an operating system? First of all, what is a system? A system is a group of interrelated components working together to solve or perform some sort of function. And there are many systems all around us. If you look at the human body, you know that all living organisms are made up of cells. When you group a bunch of cells together, you get a tissue. When you group a bunch of tissues together, you get an organ. And when you group a bunch of organs together, you get a system. So for example, in the respiratory system, you have your nose, your throat, your lungs, and so on. In your digestive system, you have your mouth, your throat, your stomach, small intestine, large intestines, and so on. So these systems are just a collection of components that have a related function. So it's not just a random group of components, it's a specific group of components that have some relationship with each other. They perform a similar function. So the term system in computers are referring to the hardware. So anytime you hear the term system, typically we refer to computer hardware. So you can see the hardware made of input, process, output, storage, and communication components. So these are the group of components. So your system software's job is to control and coordinate all of those components so that the computer can perform computing operations. Computing operations basically mean processing. Now, in case that example doesn't make too much sense, I want you to think of it this way. If you have an aeroplane is a system. You know, you have the wings, the tail, the engines, and so on. But inside the cockpit of the aeroplane, you have a pilot. And the pilot's job is to control all of the hardware components of the aeroplane so that it aeroplanes. So what does an aeroplane do? It takes in passengers, it lifts off, it flies, and it lands, hopefully safely. So take off, fly, and land. The job of the pilot is to control and coordinate all of those hardware to get the aeroplane to aeroplane. So this is the same thing that the system software is doing. The system software contains code that refer to instructions that control and coordinate the natural behavior of the computer hardware. Now, the difference between your operating system and the pilot is that the pilot is an actor. That means a person with agency, something with will. So the pilot has a will, the software does not have a will. The software is just rudimentary instructions that are performed. So anytime you run software instructions, the hardware will obey those software instructions and perform the tasks as necessary. So this is what system software is. If I were to give you another example, I'll use the human being. So as a human being now, you are alive and aware of what you're doing. So you know that you're in an SSCC class. You know today's Thursday or Wednesday. Yeah, today is Wednesday. So you are aware today is Wednesday. It's approximately 4:30. You have all that information. However, while you're sitting down listening to this lecture, your heart is beating, and the beating of your heart is somewhat regulated and controlled by your brain. You are also breathing. Your body is also digesting food. Your cells are fighting pathogens. All of these things are happening without your conscious effort. So you can consider all those background activities that are happening to keep your body alive and well as your body's operating systems operating. So it's allowing your body to do what the body is supposed to do, while your consciousness is focused on other activities. So this is how you want to imagine system software. It's something that is always running in the background, taking care of business. So if you look at the example here where we're having this online class, the Microsoft Teams application is in the foreground. It's what's allowing us to broadcast and share our screens. However, in the background, my operating system is still running. There are certain things that are still happening. Something is managing my network connection. Something is managing my camera. Something is managing my screen. Something is managing my keyboard. Something is managing my microphone. And it's performing all these actions and activities without me necessarily even knowing what's going on. So this is the job of the operating system. It contains code that controls and coordinates all the activities of a computer. What about application software? The application software are the new code that we add to an operating system to extend or increase the functionality of our computer. If you've ever installed a browser plugin, a plugin extends the functionality of your web browser. It's basically the same thing. So you have an operating system. So this operating system is running all the major functions of the computer, but now I want my computer to learn a new trick. So what do? I download an application software and I install it. So the reason why application softwares are called application software is because you cannot run an application software on its own. There must be an operating system for you to apply it on top of. So the term application means to put something on top of another, which means if you write code that is meant for an application, you cannot simply run it on hardware. That hardware must have an underlying operating system. So the term application software refers to code that you can insert into an operating system to have it run. So this is the nature of application software. Is this clear to everybody so far, so good? So we've spent a rather good amount of time to basically introduce the module. So what is the module actually covering? It's covering computers. And we will be looking at some specific nitty-gritty on the functionality of a computer and how it's implemented in the real world. So we can now proceed with the details of the module introduction. So this is all we've done now is we've defined the course. So system software and computing concepts is saying we want to understand how the operating system of a computer works and how it controls the hardware in order to perform basic tasks and operations for computing purposes. So the term computing basically means calculate or to perform activities. So let's proceed. So I'll need to first switch my screen and then we can proceed. Right, so back on the slides, we can go ahead and there we go. So we've defined what system software is, basically a set of instructions that controls computer hardware. And we want to understand what we're going to be dealing with in this module. So first things first, so let me again welcome you. My name is Abubakar. Yeah, and you can contact me via email or via Teams chat. However, I will give you a caution. There are many of you in this class. There are about 350 of you. And there are other modules that I also teach that also consist of anything between 300 to 600 students. So at any point in time, I will have up to 1,000 students under my care. So I do not typically reply to messages promptly because they're just way too many. So as a piece of advice, there are two types of questions you can generally ask me. You can ask me with things related to general academia, or you can ask me things specific to this module. If you're going to be asking me questions specific to this module, my advice is you ask it during class. Like I mentioned, first 5 minutes of my class is going to be attendance, and the last 10 minutes or so is also going to be attendance. At the time I'm done with recording and delivering my message, I will unmute everybody's mic and allow people to speak or to ask questions, whatever the case may be. So at that point in time, you have two options. You can type in your message or you can ask it while we're in class. The benefit of asking questions in class is very simple. There are some types of questions that are difficult to answer, especially in chat or email. It's easier to demonstrate, it's easier to discuss. Secondly, a question you have might be similar to another question another person has. So there's no point in me answering the same question 10, 20, 50 times. But if you ask it in class, everybody who has a similar question benefits from you asking that question. And also the people that didn't even think about the question will also benefit. So asking questions in class and discussing is a top priority for me. So avoid sending me personalized messages. Ask it in class where we can deal with it. So if you ask in class, you get instantaneous response. If you send it via chat, it may take up to a week for me to actually get around to seeing it, just because there are just too many messages coming from many students. So I'm trying to encourage everybody to talk to me while we're in class. Can I get a thumbs up if that's clear? So if you do send me a message, do not expect a reply instantaneously. The only time you'll get instantaneous reply is while we're conducting the class. Every module will typically have some type of prerequisite. For this module, there is no prerequisite, just a basic knowledge and understanding of a computer. So you basically need to know what a computer is. The objectives are as follows. An objective is what the module is aiming to do. So first, it wants to help you contribute to the achievement of the learning outcome specified for level 1. Now, when you joined this university, you would have subscribed to a program. So maybe some of you are software engineers, cybersecurity guys, AI, and so on and so forth. Well, that program that you've selected requires you to have a certain set of skills. So the set of skills have been divided up into different modules. So every semester you'll be doing a couple of modules, and every module will have some sort of contribution to that final goal of your degree. So for this particular module, this is what it concentrates on. It introduces you to the study of system software and computing concepts. So basically, what is system software and what are computing concepts? Meet the prerequisites for level 2. That means there are some things in this module that you need to carry over to level 2 as a foundational knowledge. So some of the things that you'll be learning, like some programming languages, you need to understand the computer architecture before you can fully understand how computer programs and how programming languages actually work. Also to introduce you to begin to develop student skills in relation to system software and computing concepts, and also lifelong learning skills and independence. Now, let me give you a very, very, very important message. Students these days tend to think that the university is a place where they come to study a course, and when they graduate, they now, know the course, and they can go and perform actions related to the course. That is not entirely true. Another fundamental function of the university is to properly socialize you. What that means is you are not simply here to learn just about academia. You are also here to learn how to function with other human beings. Because guess what? You're not going to be the only one in the planet, and you're going to, by necessity, be forced to associate with other people. So how you associate with other people and how you associate with professional people, you have to learn. What do I mean? If you are a software engineer, what does that title mean? It means you know how to write and build computer programs. So if you are a software engineer and you meet another software engineer, it's like you're two people from the same tribe. You have to have certain common things in that tribe that makes you software engineers. So when you learn to be a software engineer, you're not simply learning about knowledge and skills, you're also learning certain actions, certain behaviors, and so on that we call professionalism. And through that professional conduct, you can now function in a team or in a group or in a society that is an advanced civilization. So case in point, you are here to learn also how to be a human being. You're here to learn patience. You're here to learn respect. You're here to learn how to interact and socialize with other people. And this is particularly what makes this particular university very good. You have people from over 132 different countries usually. So in a typical class, it's not uncommon to meet people from at least 30 different countries with 30 different cultures. So people will be different. Part of your job is to learn about these differences, understand why people are different, and more importantly, how to conduct yourself in that environment. Because by the time you graduate, one of two things is going to happen. You either join an existing organization or you create your own organization. And if you create an organization, you have to remember whatever kind of organization that is, you are providing a product or a service to other human beings. So if you don't understand other human beings and you can't work or relate well to them, then you have no business providing them a product or a service because it won't work. So if you are a Wolverine loner type person, university is not for you. University is meant to learn and teach you how to human properly, how to talk to people, how to address people, and how to function in a civil society. It's very important that you understand that. Now, while I've said that, there are some people who personality is that they're introverts. They don't particularly enjoy being around too many people. And some people are extroverts. They love it. I'm not saying you have to love people. I'm saying in order to function in this world, you at least need to understand them and know how to work with them. You don't have to love anyone. You just have to know how to function with people. And that's very, very important. It will make your life easier. So in fact, when you join the job market, one of the most important things that companies do want is somebody who who can speak, somebody who people like, basically. You just need to have people at least like and appreciate you. That's the truth of the matter. So the aims of this module also include enabling you to create and develop skills that are for analysis and decision making. So for example, if you understand computers and you understand computer architecture, you will be able to make decisions like, do I buy the PlayStation 5 or do I buy the Nintendo Switch? You will be able to make those type of decisions. Or I'm subscribing for an internet connection. Should I get the 30 megabyte package or the 100 megabyte package or the 500 megabyte package? It'll help you make those decisions. You're purchasing a new TV. Should I get the smart TV or should I get a dumb TV and then hook it up to a Raspberry Pi or hook it up to a laptop that I'll configure with a server, with a media center? What exactly? So all of these types of practical everyday problems you'll be able to actually deal with. What kind of phone should I buy? What's the difference between the iPhone 15 and the iPhone 14? Or what's the difference between the Samsung S24 and the S23? Understanding computer architecture will allow you to be able to competently deal with these types of questions. Or somebody meets you, your parent, maybe they're old. They say, you know what, I'm thinking of buying a new phone. What kind of phone do you recommend? So you can say, all right, grandfather, you're very old and you have difficulty being able to see. You probably want a phone with a very large screen. And you want something with a lot of battery. And maybe you don't need a camera, so you won't buy a high-end phone. You can buy a mid-range phone and save some money. Basically, whatever function you're going to be executing, you can then make the decision. So this is what we mean by analysis and problem solving in terms of information technology. So any problem that is related to technology, you should be able to say something about it. Also, how you can communicate your ideas across a target audience. Now, because most of us in the IT field, we will at some point be involved in software development. Software development typically happens as a team effort. You need to know how to communicate ideas in the system, in the programming languages. So, for example, you will note that software engineers, they don't design. Let me give you a better example. If you are an architect and you want to design a house, the design of the house is not a written document. It's a blueprint. Allow me to demonstrate. So if I come over here to my web browser and I Google blueprint, a blueprint is essentially, and I'm sure everybody has seen this before, this is an architectural description of a facility, of a house. So the blueprint is the architect's way of communicating with other architects. So the architectural diagram here is literally showing you where all the walls, where all the doors, where the different locations are. And using this blueprint, you can estimate the cost of building a house, how much material you need in terms of cement, wood, metal, how many door panels you need, how many windows, and how much tiles you need, how much paint. All of that is contained inside this design document. So this architecture is a design document. Now, the architect could have written this in English language, but it's not very useful if it's written in English language. So if you write English language, You can write and explain all of this in English language. It's not going to be very useful. So when you talk about computer architecture, we are probably talking about the same thing here. Learning to communicate ideas across a target audience. So software developers have their own language, they have their own types of diagrams to describe the architecture of their systems, and you need to know how to do this, how to design it, and how to create it, and how to transmit it to a target audience. Also, as a software developer, your job is to build software. In order to build software, you have your team, which you work with, the other software guys, and you have your customers who are not software guys who you also have to communicate with. So learning how to communicate with people becomes very important. The use of uh, quantitative and in fact qualitative skills. So how to measure. And ICT. ICT here stands for information, communication, technology. So how to use all of these different software. So for example, right now we're using Microsoft Teams, which is basically an ICT tool. So this software we're using is helping us to actually manage ourselves and communicate, and also to manage your own personal study. At the end of the day, this course learning outcome is your exam schedule. This is what is going to come out in your final exam. Of course, in this case, we are talking about the test that we have. This module doesn't have an exam. I'll explain later on. So you are required to be able to explain the basic principles of computer systems and how hardware components work together, basically computer architecture. You are also required to be able to use operating system concepts and functionalities to assist you in choosing a suitable system based on a given scenario. That means if I wanted you to build me a certain type of application, you need to give me all the specifications as it relates to software. Then thirdly, to work in a group to explore the features of system software and hardware performance of a chosen computer system. In other words, working well with other people. It's a very important skill that you have to understand and learn how to. So this is our course mapping. Here you have this module, these three learning outcomes that I've stated, 1, 2, 3, are represented here as CLO1, CLO2, and CLO3. And you can see how they map to your program learning outcome. What is your program learning outcome? Whatever your degree is, it will fundamentally require you to develop all of these skills, these 11 skills. So you have knowledge and understanding. You have to know things. That's where you learn new words and language. Cognitive skills, what you can remember. Practical skills, the tools that you can use. So for example, if you know how to use a software development environment like Eclipse or Notepad or Visual Studio Code, these are practical skills. Knowing how to use Microsoft Word, how to use Excel, these are considered practical skills. Interpersonal skills, how you interact with other people. Kindness, compassion, respect, that's interpersonal. Then communication, how well you effectively communicate in written and verbal forms. Digital skills, the tools that you can use, the technology tools that you can actually use. Then you have numeracy skills, which is basically math, your ability to mathematics well. Leadership, autonomy, and responsibility. It speaks for itself. And personal skills, how you deal with yourself. Interpersonal, people, you and other people. Personal, you and yourself. How to take care of yourself. For example, do you brush your teeth? Do you eat healthy? Do you exercise? These type things. So there are modules that will actually cover those aspects of how you conduct yourself and how you deal with yourself. How do you tackle laziness? How do you tackle anxiety? How do you tackle depression? So these are all things that you learn in the university setting. Entrepreneurial skills. There are modules that are designed for teaching you how to create businesses. And lastly, ethics and professionalism, how to behave amongst people. For example, the business people will tell you the customer is always right. So that's a professionalism attitude. Or if you are working in a company and a customer comes and the customer is upset or angry and starts shouting at you, and so you're not supposed to shout back. If they insult you, you're not really supposed to insult them back. So there's a certain kind of majestic attitude that you take towards these kinds of things. So you rise above other people. That's what it means to be a professional. So a professional, even if you spit on him or you insult him, he doesn't behave like you. If you come and you behave like a fool, the professional doesn't respond to you by behaving also like a fool. So you insult his parents, he insults your parents. That's not professional at all. To be a professional means to rise above others, essentially. This is part of the reason why this university has a dress code. You will note that all your lecturers are required to wear suit and tie. And to some extent, we also recommend students to also dress up responsibly, because people will treat you how they perceive you. So for example, I want you to just close your eyes and imagine you're in a lecture class and your lecturer walks into the class and he's wearing shorts and a vest. He has a gold chain and he has a skull tattoo on his arm. And maybe he's smoking a cigarette and he just steps into the class. Now, if you're a normal person, that will immediately start to worry you, because the person is not dressed for the particular role. Or worse yet, imagine you go to the hospital and you're talking to a doctor, and the doctor is like, "What's up, my man?" And he's talking to you in a very informal tone, you know? And maybe as he's talking to you, he has music blasting in his office. It's a very unprofessional environment and you will not feel secure. And this is the important thing. You need to understand that how you dress affects how people treat and perceive you. You dress like a punk, don't blame people to treat you like a punk. You dress respectably, you dress expensive, people will be like, all right, this guy looks, well dressed, you know. So you trim your hair, you brush your teeth, don't fart in public, and you behave yourself, and people will generally like you and at the very least respect you. So this is all professional and ethics. So now it's important to understand that how people feel about you in some setups is important and in some setups not very important. But the most important thing is that you do the right thing, and that's what professionalism is about. So our module only touches on PLO 1, 2, and 4. So you have the knowledge and understanding bit, the cognitive bit. So knowledge and understanding is what we know. So I'm teaching you things about computers. We've already learned what a computer is and that a computer has two main components, hardware and software, and so on. Cognitive skills is how much of this you can actually remember. So there are certain things that when I teach you, I don't need you to remember it off head. You just understand and you know. But there are certain things that I need you to be able to memorize, that at any point in time, we slap you awake, we ask you, what is so and so? You should be able to tell us as an IT person. And lastly, interpersonal skills. So the interpersonal skills has to do with one of your assignments. It's a group assignment. So how we're going to force you, and yes, we're going to force you to do work with people you probably don't like. And the goal of that is to learn to thicken your skin, to learn how to operate in uncomfortable circumstances. It's part of the learning process. So when we set you up into groups, don't come and say, "Oh, this member isn't working too hard." That's not the point of the activity. The point of the activity is, are you able to influence other people to do well? And if not, if you found yourself in a community and some people were not good people, how would you deal with yourself? Because at the end of the day, the job needs to be done by somebody. So as a lecturer, my business is make sure the job is done by any means necessary. Don't kill people or anything, but by reasonable means necessary. So let's put it that way. You don't force, you don't abuse, you don't insult people, but you try to influence them. And if you try, you fail. How did you fail? So I'll talk to you about that when we get to the assignment bit. But this is the part of the module. So you will notice here that for each of these learning course learning outcomes, there are teaching methods. So most of it is teaching in the lecture and the case study. And then there are methods where we test it. So for CLO 1 and 2, we're testing it in test 1 and 2. So what you can remember and what you know. And for the group assignment, we're testing CLO 3, how well you work with other people. So we're not necessarily testing you on the quality of the product that you deliver. We are going to be testing you on the quality of your ability to work with other people to produce that product. There's a subtle difference there. So this is the what we call the Malaysia's uh, Ministry of Education. So MOE stands for Ministry of Education. So the Ministry of Education has dictated to all universities the skill set that all IT degree holders should have. So the MOE, these are the skill sets that they say everybody should have. In our university, we have mapped those to our module learning outcomes. So everything you see here has been mapped onto something here, which relates to this table that we're showing. So by the time you finish your 3-year study, you have all of these knowledge and skills from an IT point of view. So let's talk about some important things now. What is my job as your lecturer? My job is essentially to be like a friend who gives advice and shows you the way. I am not a teacher. I am a facilitator of learning. There's a subtle difference. A teacher is concerned with forcing you to do things. A lecturer assumes you are an adult and you know exactly what you're doing. So if this was a physical class, as a lecturer, I was walking around, maybe I'm delivering a lecture, and I see you sleeping. I'm not going to say, look at that bad student. How dare he sleep in my class? I will be like, this guy must have had a tough night, and leave you alone because I assume you know what you're doing. So I will always look at you, whatever it is you're doing, I will always assume that you know exactly what you're doing. You're an adult. If you ask me for help, my job is to be there to help you. So there's a particular concept that is confusing you. You don't understand a certain piece of technology, you can talk about. But don't ask me for money. That's not part of my facilitation of learning. So my job is academic. If you have any issues academic, then you can come up and say, hey, I have this issue. This is a concept I can't understand. Can you help me? My job is to help you with a smile. For you, as a student, you need to be aware of two things. You need to implement common sense. Part of common sense means how you behave and how you conduct yourself in class and outside of class, how you interact. So in class, common sense means ask questions if you have questions. Don't be shy. Even if you're a shy person, do your best to interact with me. Do not do anything in class that will disrupt your fellow students. So that is what common sense and interaction is. So if you're in a physical class and you have a phone, make sure your phone is on silent. If you need to answer a call, try to take excuse, leave the class, answer your call and come back. But don't do anything that will disrupt anybody else in the class. So that is the common sense. Interaction, make sure you talk to your lecturers. You have a problem, you're having an issue, something you don't understand. Remember, my job is to teach you. I already know the subject. So when I speak, I'm not here to teach myself. So if I'm speaking to you and I'm giving examples and it's not making sense to you, it means we're wasting time. You need to ask questions for clarification so that we help you. The approach I use is basically there's a lecture and there's a tutorial. So in this particular setup, I'm only responsible for your lectures. Your tutorial is going to be handled by Miss Vijaya. So Vijaya, you probably have already met her and you're probably going to meet her face to face. So during her sessions, she will be asking you questions which you need to provide answers for, and she'll also provide you with some space to communicate. With regards to lectures, I will do most of the talking. In the tutorial, you will perform work. In the lecture, you will listen and we will communicate. So in the lecture, there's an opportunity for you to ask questions and for me to provide you with answers. With regards to the tutorial, you will do work. I keep my approach very simple. I make some jokes and I give a lot of examples. In fact, sometimes I give so many examples, people wish I would just shut up. So if you happen to be one of those people, you have to bear patiently because I give many examples, not because I particularly like to hear myself talk, but you have to understand that amongst these 350 different people, there are people that are coming from very different backgrounds who need those examples. So if I give one example, maybe 50 people will get it. If I give a second example, another 50 will get it. If I give another, maybe another 100. So I will typically give quite a number of examples. So be patient with that. It's not done out of carelessness, so to speak. So I try to keep things simple and I'll give examples in whatever manner I feel effective. So I might even reference a movie, for example, just to try and explain a concept. You also will do well to take notes during classes. So as we cover these topics, although this is just an introduction, when we cover these topics, you want to be taking down notes because every thing that you're going to be faced with in the test, I'm going to be discussing it in class. So the slides are basically short form notes. They don't contain all the information. The main information is in the textbook. But as we're going through the lectures, I might give you some interesting pieces of information that you will not find in the slides or in the textbook. So for example, that diagram that we drew today, the IT and the definition of IT and the difference between the two computing components, all of that is all extra. You're not going to find that in the slides. So taking down notes, very important. And you also remember you have the video. So all recorded sessions will be available for you to access at the end of the day. So my desire for you is to succeed. Now, sometimes students think that the lecturers are evil and they're the good guys. And basically at the end of the semester, you have to go, fight and kill the bad guy. The truth is far from that. The lecturer's desire is for students to succeed, believe it or not. No matter how harsh we may appear to be, our job is to make sure you enjoy the entire experience and, more importantly, you benefit from it. It is not important that you enjoy it. It is important that you benefit from it. Sometimes to benefit, we have to put you through difficult situations. We have to be sometimes very harsh. We have to be sometimes very strict. And sometimes we also can be nice. So the idea is we want to strengthen you. We want to prepare you for the real world. The real world is a nasty place. You've lived long enough to be able to understand some aspect of the difficulties and challenges of living in the real world. So you have to prepare for it. And the best way to prepare for it is through practice. And that is what the university environment is supposed to provide you with. Also very important, there are some students that focus on knowledge and they ignore examinations. For example, you will meet friends of yours who will say, I just want to learn how to do this thing. I don't care about the grade. I don't care if I get an A or a B or a C. I just want to know how to write computer programs and develop code. Now, that is commendable, but at the same time, you need to understand something very important. When you graduate, chances are very high that you need to first spend a couple of years working in a company, learning more skills before, if you decide you want to build your own company, it will come typically later. As a young person, it's unlikely that you will just graduate and then build a company. It's not even a good idea. You need to practice. You need to go into organizations, see how they function, then go build your own. In order to do that, you need to be given the opportunity. In order to be given the opportunity, you need to have a good grade. So the purpose of a grade is very interesting. A grade at the end of an examination does not reflect your intelligence. In other words, if you get straight A's, it does not mean you're going to live happily ever after. An A in a module simply means you prepared well for that particular module, full stop. It doesn't even mean you're smart. If I have an exam and I've told you 5 topics are coming out in the exam and I require you to go and master those 5 topics, you go read them, you do your best to understand them, and you sit for the exam, you'll be able to get the A. But it doesn't mean you understand what the hell you were doing. It doesn't mean if I ask you to create something new, you can create it. It doesn't mean, it just means you know it. You've read it, you've understood it to some degree, and you can regurgitate it. It's important that you get the good grade because when you graduate and a company is looking for somebody to hire, there are too many of you. So imagine I'm a company, I need to employ 5 people and I receive 5,000 applications. I am not going to sit down and look at every special snowflake and interview every special amongst the 5,000 people. They're not going to do that. They will say, all right, we have 5,000 applicants. Let's filter out. Let's just take all the first class degree holders. So right off the bat, they've dropped 80%. So now you have a couple of 100 people left. In those 100 people, they'll now start looking at what skill sets do these people have, how old they are. Some companies will prefer in some roles to hire male or female, whatever the case may be. They'll filter you. So at the end of the day, there will just be a couple of 100 of you. So those couple of hundreds are those that get the interview. So you want to also strive to get a good grade. Now, remember, sometimes when you strive, you are not always going to be successful. If you get an F, does it mean you're a bad person, you're going to hell? No, it simply means you did not prepare well. So the reason why organizations like to hire people with first-class degrees, it's because the A is not a statement of intelligence. It's a statement of dedication. It means you're the kind of person, if they give a job to do, you are likely going to finish it on time and according to specifications. In fact, you can even make an argument that the people that get A's are really stupid because they're very uncreative. They just follow the rules. They're not very creative. They're not radical. You can actually make an argument for that. You tell them to do something, no matter how stupid it is. All right, yes, boss, I'll do it. That's the A people. So this is not, I'm not disparaging the A people or anything, but you want to get the A. So the A communicates to the organization that you're a person who, if you're giving a job to do, you will probably do it well, finish it on time, and do it according to specification. So that is why you need a good grade. The next thing is you need to also understand the importance of what you're doing. Your parents are sacrificing a lot of money for you to be here, like 25K a year, and that's just the tuition, not to mention the food, the accommodation, and the pocket monies, and so on and so forth. And you can do a lot with 25K. You get it? So make it worth the while. Don't waste your time here. The 3-4 years you have in this university is opportunity for you to develop yourself. So don't just focus on what is in the class or what is in the module. Try to go outside the box. Register, subscribe for different learning online platforms. I'll introduce you to a couple. Subscribe, pay the 80 ringgit, 20 ringgit, however much it is monthly. Instead of a Netflix subscription or a PlayStation subscription, subscribe to those things. Learn how to code before the coding class. Learn how to do software development before you actually do the software development class, so that by the time you graduate, you become a seasoned all-rounder. Now, the tests, there are going to be two. The first one is going to be middle of the sem. The second one is going to be at the end of the sem. The in-course assignment also will be submitted at the end of the sem. So there will be a particular week, 2 weeks, 3 weeks from now, I will sit with you and discuss in detail the in-course assignment in detail. But this is the specifications. You are also expected to invest 61 hours in this 14 weeks to study this module. This is your independent study alone. So your reading of the textbooks, your doing of your assignments, your preparation for the test, and so on, should at least be 61 hours. So what you want to do now is, on a weekly basis, you might consider creating a study group, you and your friends. You meet up maybe once or twice a week. So everybody has their private study time. You study privately, and then you have a group study time, maybe twice a week, so that you can sit down, have fun, engage, and then try to ask each other questions and answers, work on assignment, get ideas, and so on. It will help you, and it will go a long way. The way some people like to play basketball, football, badminton, squash, and so on, they have their groups. Also create a study group. But it's also important that you have your own personal, individual study time, so that when you go to the group time, you have something to contribute. We will be focused here on lectures and tutorials, which will be about 24 hours for the 14 weeks and 18 hours for the tutorials for the 14 weeks, approximately. So I've already mentioned that we're moving to something called outcome-based education. This is the Malaysian Ministry of Education requirements, where we teach students and prepare them for the real world. So that's what outcome-based education is, basically producing skills or helping you learn skills that will be useful when you graduate. So here's the outline of the topics that we're going to be covering, amongst other things. Next week, we are going to start with a basic introduction, where we will discuss many of the things relating to computers and the whole foundation. Then we will look at the general concepts of computer architecture, data representation. We will be looking at logic gates, components of a computer, CPU and memory, input and output devices, and of course, operating systems at the end. We will also learn how to install different operating systems on virtual machines. We will also learn how to configure those machines, and so on and so forth. So this is not the fixed outline of what we will be covering. This is just a generic outline of what we will be touching on. We won't touch on every single aspect here, but for the most part, we will be delving into many of these. So we will have tutorials and case studies. So there will be some sessions where we will be installing a virtual machine, downloading a new operating system, configuring it, and so on and so forth. So when that time comes, we will engage in that. So at the end of the day, please obey the general rules and regulations of the university. When online, conduct yourself properly. When physical, also conduct yourself properly. The rule is never do anything that will disturb other students. These rules are not for the lecturers, they are for your fellow students, to make a healthy, conducive learning environment. Do not tease people, do not bully people, do not denigrate, do not insult, do not slander, do not backbite. All of these are bad traits, and they make for a terrible learning experience for the community. You want to try your best to be as civil as possible. Do not do to somebody else what you do not want done to you. That's just a general rule of human decency. So try to enact that. Dress properly, brush your teeth, don't fart in public, and I think you will do just fine. So the resources that I mentioned are available on Microsoft Teams, and you can download them. So as I mentioned, on a week-by-week basis, you can go ahead and download them from the file section. I've already shared this document with you. This, the architecture of computer hardware, system software, and networking. It's available right now on Teams. So you can go ahead and download it under the class materials. Under class materials, lecture slides. This is the slide for today, and the textbook, you can go ahead and download it from the file section down here. And basically that's it. So there are a few final questions that we want to quickly address. We are going to be studying computer architecture and system software, generally speaking. In order to do that effectively, we need to understand the context in which we will be studying. We will be studying particularly with a focus on organizations. So when we discuss computing and computing technology, we're not going to be discussing it from a user point of view. What's a user? You are a user. You can go into the market, buy a phone, buy a computer for your own personal use. So as a user, your personal use might include, I want something to be able to browse the internet, maybe play a couple of computer games, store my music and my media, and so on. For an organization, computers have a different connotation. They are meant for producing work. So you need to understand what organizations require. For example, as an organization, if I was running a company, I might have 500 employees. So I might need to go into the market to buy 500 computers. Now, even if there's a difference of 100 ringgit between one computer model and another, if I'm buying 500, that 100 ringgit difference becomes 500 times 100, which is like 50,000, right? So organizations, when they're making purchases or when they're making considerations, they consider bulk buying, the architecture, how this computer will fit into their own environment. And we'll talk about this all in next week's lesson, the first introduction to computers. We also need to understand what a system is. We've already defined that. We said it's a group of interrelated components. It's not just a group of components, it's a group of interrelated components working together for a specific function. What is a network? A network is a collection of communicating computers, a group of communicating computers. What is a computer? We said it's an electronic device that can accept input, process it via a set of instructions, and produce output. Now, a computer doesn't mean desktop, doesn't mean laptop. It means anything that can do input, process, and output. My game console, my PlayStation, is a computer. My smart TV is a computer. My smart projector is a computer. My smart washing machine is a computer. You get it? So don't just think desktop and laptops. Anything that can perform processing is a computing device. And a computing device is a computer. So what is the purpose of computer networks? For communication. So the computer is the main tool in IT technology. And IT technology also involves the distribution and dissemination of information, which is done through computer networks. So the primary purpose of a computer network is for transmission of information. And we're done. So if you have any questions, now is the time that we can begin to deal with those questions. So you can head on to the chat area and start typing away for any questions you wish to have clarified. In next week's class, we will look at the introductions to computers and a general overview of computers. So as said, I will be stopping the recording at this point, and then I will address all questions that you may have. Also, I will then display the QR code for those who were unable to take the attendance or for those who were late. So remember, all the resources are available in your file section. So if you come to your file section, there will be two folders here. Right now, the second folder isn't here, but the second folder is going to be called recordings. So all class recordings will appear inside this folder and they will have a date and timestamp. So the minute I stop this recording, it will save. After 15 minutes or so, you will see a new folder here called recordings, where you can access all recorded classes. In the class material section, you have your lecture slides where I will be uploading weekly. And in the textbook section, you already have the textbook, the PDF for this module ready to download. So you can go ahead and do that now. So I'll stop the recording and then I'll begin the Q&A.